comments, questions, or concerns about any piece of your homework? Let's do it. I assigned 2 pieces of homework. The first one I wanted you to do was the bed mass questions. Are we cool with the bed mass questions? Anything you want me to go over there? I assigned 3 to 5, 8, and 10. Hearing nothing. I'm going to operate on the assumption that you did it. Like in this section or in the next section? Okay, we'll get question 10. Like from the next lesson? Well, there was 2 sets of homework though. There was the bed mass homework and then there was the second homework. Okay, I'll get there. So there's no questions about bed mass. We're good. Yes? Hearing nothing? Okay. I'm really assuming that once if there are questions that you're going to ask them. The next chunk was a lot bigger. It was 4 to 6, 8, 9A, 10 ACEGI, 13, 15, and 19. So I'm hearing that there was questions out of number 10. Yes? Are there any questions earlier than 10? Danny?
So with 5.
With 5.
Yeah. With that, hold on. So when you're dividing a negative by negative, but there's like with D.
With D, yes.
What would be? I don't know. Should I put that in brackets or should I put?
Yes, because all you're doing is you're just simplifying the exponent. You're not evaluating anything.
So is it?
So the base, because this thing's in brackets.
Is it negative 6 in brackets with a 5?
You betcha. That's exactly what it is.
Okay.
Yeah. And then if I asked you to evaluate, you could then go deal with that. But that is exactly how you'd write it.
Okay.
Okay. So any other questions, like leading up to 10? There's no questions prior to 10. Going once, twice, 3 times. Okay. Kyla and Angel. What's your question about number 10? Simplify is just using our exponent laws to condense the question. Like writing things as single powers. So like in A, I wanted you to do, so in 10 I wanted you to do these ones, ACEGI. So you have 10 squared times 10 squared plus 10 to the 4. So 10 squared times 10 squared, what do I do when I multiply? If those bases are the same, when I multiply, what do I do with the exponents? I add the exponents. So this first piece is going to become what? 10 to the power of 4. So this one is going to give me, I'll just do it over here. So I'll have 10 to the power of 4 plus 10 to the power of 4. Sorry? That was actually the question I was just about to ask you. Am I done? I simplified it because I've simplified the exponents, yeah, because I've got 10 squared and 10 squared multiplied together. When I'm multiplying the same bases, I add the exponents, so it's 10 to the 4 plus 10 to the 4. Now at this point, as far as the powers go, using our power laws, that is as simplified as we can get. Now we can evaluate it. 10 to the 4 is 10,000. It's 1 followed by 4 zeros. So I've got 10,000 plus 10,000, which is going to give me 20,000. So I want to see both those parts. Sorry, which one are we looking at? C, you got what? How did you get 99 billion for C? Yeah, that makes sense. No, that makes sense. Yeah, that's fine. That's fine. Yeah, I don't understand that. One of my grade 12s came to me the other day and she's like, I did a test and my numbers all looked weird, but I put them down anyway because I didn't know what else to do, and they were right. I'm like, what does a weird number look like? What do you mean is a weird number? But look at what you got here. You got 10 to the 11. That's 1 followed by 11 zeros. Like, that number is gonna be massive. But it's just another number. But why do you assume? Okay, so that's something I genuinely don't understand. That just because the numbers are really, can you maybe try and help me understand that? Like, what about? Okay, so you've got 10 to the 11. That's going to be 1 followed by 11 zeros. Like, you're cool with that, right? 10 times 10 times 10 times 10 times 10. So the number's going to be big. So it's 10 to the 11 minus 10 to the 9. So that's, I need more space down here because you're right, those numbers are big. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 minus 1, 2, 9. Bam. So that's just going to be, right, so you're okay, you're right. So that's 100 billion minus 1 billion. So, oh yeah, okay, so you're right, that's 99 billion.
So that is weird. Like, that's just not. It's just weird. It's an answer. It's an uncomfortable answer.
Okay, Danny?
In all my years of being in math class, like, we've never, the most I remember, like, 1 million maybe, but it was like, oh, the answer's 1 million. Like, I never remember, it was always, usually the equations would be up to 1,000-ish, or maybe 1,000 something, 9,000
Okay.
maybe. Like, it was never that big at all.
Well, welcome to all of the integers.
Yeah.
Presley.
I feel like with like powers and stuff, if the base is 10 and the exponent is too large, like I don't think that's very weird. But we had a question on like the math contest we did that was like 4 to the power of 121 plus 7 to the power of 123 plus 5 to the power of something, and then you have to find like the last 2 digits. And that was like, yeah, but you have that integer calculator.
That sounds wild.
Yeah.
That sounds. Yeah, and the reason on that contest, the reason they do that is so that it is bigger than your calculator is able to compute.
Yeah.
I like it. I like it a lot. Yeah, leaving that blank. Like, there are neat little tricks. We can talk about it if you want.
Yeah, okay.
I can show you how I would approach that. I might be wrong, but I can show you how I would approach that.
The test. So
Nice. Yeah, hang on to those. Okay, so that's good to know. But just because the numbers get really big, I do want you to fight through that just because the numbers get big or the numbers are looking weird and you're not used to seeing what they're there, that doesn't mean that they're necessarily wrong. But fair enough. You've also got the answer key so you can see what, like remember, like I gave you the textbook answer key. It's in the Google Classroom. Does anyone need to see where that is again? You just want to see it? Okay, okay. So here we go. I'm going to toss this into the video as well so we can see what's happening here. So if you go into the Pre-Diploma Math 9 Google Classroom and you go down here to where it says in the course info section where it says textbook answer key, these are all grayed out for you. You don't actually see these bottom ones because I don't know why, but material gets gray for you. So then you open this PDF, and it's going to go slow because I'm recording all this. This is page 76 in this textbook. So you're going to scroll down, you're going to ignore all this garbage until you get, like, you see where it says like homework page whatever. So we're going to go further. That's page 61. I don't want page 61. I want to go further. That's page 69. I don't want to do that. We're up to 76 already. Have I passed it? Oh, maybe there's. Oh, that's 87. So I passed it already. Well, this is the page number in the textbook. Here it is. Page 76 is where the homework starts. So this is page 76, question number 10. So there it is. 99 billion. There's the answer. So 10 is going to be 10 million and 10. That's D. E is just going to be a million. G is just going to be a million. Yeah, A, C, E, G, and I. And then I is going to be 100,000. There you go. So there it is. Do definitely feel free to check your answers, especially when I give you the textbook stuff. I apologize if that was a little confusing to you. So, any other questions from the textbook work, the homework I gave you last night? I also gave you 13, 15, and 19. We're cool with 13, 15, 19? Okay. Nothing going on. There's 15 up at the top. Here's 19. No questions. Going once. Okay, you ladies at the back, I'm assuming there's no questions because you're not paying attention. So well, let's move on. Lesson 4, Exponent Laws, Part Dos. Lesson number 4. Or fear. Or... I used to be able to say my numbers in Punjabi and I've lost them all. It's true, I could. That's what happens when you're 5 years on a dairy farm. Okay, here we go. So, we've done 2 laws. Let's introduce to you some more. This, I think, is still technically review. Law number 3 is what's called the distributive property of exponents. When I have something like this, x, y in brackets to the power of n. What's happening with x and y? They are getting multiplied together. So the distributive property, I want you to put a star underneath distributive property. This only works when multiplying in brackets. And you'll see why I make a big deal about this later. Yes, Danny?
So what would be the base of that? I don't know if that's a silly question or not.
No, that's a good question. I was going to ask that, actually. So I've got xy in brackets to the power of n. What is the base on that? The base is whatever the exponent is on. And the exponent, is it inside the bracket or outside the bracket? It's outside the bracket. So the exponent is on everything inside that bracket. So then my base is going to be what? X times y.
Oh, that is like
That is the base, yeah.
Okay.
So it's no different than if I had like a negative 3 in brackets to the power of n. My base is going to be negative 3. Well, what is negative 3? Negative 3 is just negative 1 times 3.
Right.
So my base, in this case, even though I've just got letters in there, that whole thing, because it's contained in a set of brackets and my exponent is outside, that whole thing becomes my base. The way the distributive property works, I'm not going to write it down. We're actually looking at an example here. What does, and then we'll go back and fill this section in. What does this mean when I have 3a in brackets squared? Carolyn? Yes, that is the secret workaround that we're coming towards. What does it, but I want to get there first. What does it mean to square something? Multiply it by itself. So what I wanted you to see was that 3a in brackets squared means I've got 3a, not 2, I've got 3a times 3a. Okay, if I have 3, yes, Danny?
So how is 3a different from xy? Because x is like xy is x times y, but then 3a is just 3a. But
Well, it's 3 times a.
it is 3 times a.
Yeah.
Times 3 times a?
Yeah, because I've got it to a power of 2. So 3a in brackets squared is 3a times 3a. The reason I'm not doing this with x, y, and n is because n is not a number yet. It would be xy times xy times xy times xy n times. So I'm using the example to give us the rule that we're going to put up in here.
but it is 3 times A times 3 times A?
Yeah.
Okay.
Yes. That is what this means when I have 3A in brackets, I'm squaring it. So I can rejig this, right? When I'm multiplying, so I've got 3 times, as Danny just said, I've got 3 times A times 3 times A. I can multiply in any order, right? Is 2 times 4 the same as 4 times 2? So then I can reorder this, and I can say, well, this is just going to be 3 times 3 times A times A. Are we cool with that? Well, 3 times 3, I could just write that as 3 squared, yeah? And then A times A, I could just write that as A squared, yeah? And which is exactly what Carolyn said we were going to get. And then 3 squared times A squared, that's just going to be 9A squared. But the thing I want you to see is the connection between this and this. What did I do? Is there a shortcut I can make to get from here to here? Danny.
Remove the brackets and put another 2 over the 3? Or is that's just what you did, kind of, but not really? Like, take away the brackets and kind of place the 2 over the 3.
Effectively, that's what I'm doing.
Yeah.
Have you guys heard this word distribute before in mathematics? Okay. To distribute something means to apply it everywhere inside a set of brackets. And then you can drop the brackets. So what I'm doing here is I want to use the language in the problem. Instead of saying that I'm going to copy and paste the thing because you guys don't have the language for it, what ends up happening is here we distribute, gentlemen at the back, we're talking about this, right? Not something else. When I've got 3A squared, 3A in brackets all squared, what I can do, because I'm multiplying in the brackets, is I can distribute that exponent onto everything being multiplied together in the brackets. So I've got the 3 becomes squared and the A becomes squared, allowing us to jump straight to 3 squared times A squared, which then is going to give me 9A squared. I evaluate where I can. Danny.
So if we knew what A was, what would...
If I knew what A was, then I could evaluate it.
So, yeah, kind of. Like that's the furthest we can get. We don't know what A
Yeah, if I gave you a value for A, then you could evaluate it further. If I told you A was 2, then we'd square 2 and multiply it by 9.
Okay. Oh, okay.
So then 2 squared would be 4, and 4 times 9 is 36. So if I gave you a value for A, you could go further, but we don't have it, so we're done.
Okay.
So then what I want you to see here, in general, if I have x, y in brackets to the power of n, I can write this as x to the n times y to the n. It only works when multiplying these things in brackets, and this thing has a name. This thing is called a power of a product. This law, because I'm taking a product and I'm putting it to a power. Do you guys want to see now or later why this doesn't work with addition? Okay, so this only works with, actually, I'll show you after number 5, because 5 is going to be important. Okay. So that's the first one. We're cool with that? Have you seen this law before? Some of them get shown in grade 8, some of them don't, and I never know where that line is because math teachers in grade 8 change the bar every year. So here we go. That's the first one we're going to do today. The next one is here, law 4. It's a power raised to a power. So that's actually very similar to the name I'm going to give it. I'm going to call this next one the power of a power. And to actually figure out what happens here, I want to do one of these examples first, and we're going to see what results. So, I've got 4 squared in brackets, and then I'm cubing that thing. What does that mean based on the exponents that I've been given? Danny.
So you would do what's inside the brackets first.
I don't want to evaluate it.
Yeah, evaluate it.
I don't want to evaluate it.
Don't. Why not?
Because evaluating doesn't show us how these things work.
Because I thought that you would do 4 squared, so you'd have 16 and cubed.
I'm going to go with the first thing you said there, which was 4 squared. So 4 squared is, it is 16, but I don't want to evaluate it. So how else? So you can express it as 4 times 4. So 4 squared is 4 times 4. And what am I doing with this 4 times 4? I'm cubing it. What does it mean to cube something? Multiply it by itself 3 times. So what I'm going to do here is I'm going to take 4 times 4, and I'm going to multiply it by 4 times 4, and then I'm going to multiply it by 4 times 4 again. So I'm going to multiply this by 4 times 4, and then I'm going to multiply it again by 4 times 4. So what do I actually have here? I've got 4 multiplied by itself 6 times. So this thing is actually going to give me 4 to the power of 6. So do we see a shortcut here? Carolyn? What you can see here is if we the long way gets us there, but the shortcut, what I want you to see is you can actually, when you've got a power to a power, you multiply the exponents together, and that'll give us our final simplified version. So if I have x to the power of m to the power of n, how could I then write this? There's no numbers there. How would I write it? X to the power of m times n. Absolutely. In general, that's what we're doing here. So what we're going to do now is we're actually going to combine laws 3 and 4. We're going to take law 3 and we're going to take law 4 and we're going to combine them to do 3 more examples. This was our lovely little example for power of a power, and now I want to combine 3 and 4 to do these bottom ones. So, if I combine these things, what have I got here? Danny.
Like 6 times 3, or is it, no, I don't know, hold on.
You can go back, yeah, yes?
2a to the power of 6 times 3.
Almost. I just had to make sure I was understanding what you were saying, because you did. When you got to be careful when you read these things, because you got to emphasize different things. I put breaks in there just to give me the brackets. You're almost correct. If this 6 was just gone, I'm going to zoom this in so we can see a little clearer. If that 6 weren't there, come on, focus, thank you. And this thing were just 2a in brackets to the power of 3, what would I do? Carolyn, I see that hand.
No, I just wanted to tell that it's not 2a power of 6, this time it can be 2 times a to the power of 6 times 3.
Yes. Yeah. So if I had 2a there and I didn't have the 6, what would I do with that exponent outside the brackets? I would distribute it onto the 2, and I would distribute it onto the 3. Sorry. Distribute onto the 2 and distribute onto the a, which was law 3 that we gave you. Yes? We're cool with that? So let's do that. I'm going to take this exponent, and I'm going to distribute it onto the 2, and I'm going to distribute it now, but I don't have a, I have a to the 6. So I'm going to distribute this thing then onto the a to the 6. So this thing is going to give me, the first piece is going to give me what? 2 to the 3 times a to the, yeah, and this is where law 4 comes in. Now, when I had 2 here, there was no exponent. When there is no exponent written, what do we assume that the exponent is? So 1. So basically, we are actually using law 4, because I have 2 to the 1 to the 3, and 1 times 3 is 3. Here I've got a to the 6. 6 times 3 is 18. So I'm distributing that exponent in, and I multiply my exponents when there is one present. So The 6 times 3 is going to, so I'll write it out like this. So 6 times 3, which is going to give me 2 cubed times a to the 18. Does that make sense? Does anyone want me to show you like the long version of it using repeated multiplication? Are these questions, or you want to see it? Want to see it? Okay. So like the other way I could show it to you, if I have 2a to the 6 and then cubed, I could have written it like 2a to the 6 times 2a to the 6 times 2a to the 6, which I could rejig. I could write 2 times 2 times 2 times a to the 6 times a to the 6 times a to the 6. And you'd see that this is going to give me, when I have 3 2's multiplied together, I can write that as 2 cubed. And then I've got a to the 6 multiplied together. So this is going to be, when I multiply it the same base, I add the exponents. 6 plus 6 is 12 plus 6 is 18. So you can see here that it gives me the same result if I expand it into repeated multiplication, then use one of the other rules. Or I could just shortcut it using law 3 and 4. When I've got brackets and an exponent, I can distribute it in when there's multiplication inside. And then when I've got a power to a power, the exponents multiply. So I combine those two, and I just go straight to here. Danny.
So why wouldn't you solve what you can with the answer, like cube 2, and then put it times a?
I totally could. 2 cubed is 8. So then I've got 8a to the 18, and that is as far as we can take it. This is done.
So you distributed the 3.
I distributed the exponent in, yeah. And then I multiplied the existing exponent with that 3.
Because it's 2a, or 2 times a to the 6.
Yeah. Or you think about it, it's 2 to the 1 times a to the 6. When I distribute that exponent in, I have to multiply them together. 1 times 3 is 3, which is where this came from. And then 6 times 3 is 18.
Okay.
So I got 2 cubed times a to the 18. And then I
I did
can...
want to do 6 times 3 at some point, but I forgot that I thought it was 2a to the 6, not 2 times a. Yeah.
They mean the same thing. 2a to the 6 and 2 times a to the 6. That's, we understand in math those to be the same thing.
Okay.
Okay, next one. What have I got going on here? Top one. Carolyn. So what I'm going to do here, yes, what I'm going to do is I'm going to distribute the 4 in on both of these. So this is going to be x to the power of 3 times 4 times y to the power of 2 times 4, which is going to give me x to the and y to the, and we're done. Cool. Comments, questions, concerns? This is just an application of those two laws, 3 and 4 together. Yeah, Danny?
So you just distribute the exponent and then multiply the exponent
You betcha.
by
By the existing exponent, yeah.
okay.
Okay, and then the last one, I've got 3a cubed, b to the 4, c to the 6. What do I do?
Distribute the 2.
I'm going to distribute that 2, and you got to distribute it everywhere. So it's going to get distributed onto that, that, and that. Every piece multiplied together needs to have that exponent applied to it. So what am I going to have here? Carolyn? It's going to be 3 squared, a to the 3 times 2, b to the 4 times 2, 6 times 2, which is going to give me a final answer of? Yeah, you can. So 3 squared, you want to say 9. I hear. Okay, keep going. A to the 6, b to the 8, c to the 12. Cool. I love it. Do we understand what she did? With these things, when you've got coefficients, if you left this as 3 squared, I would not mark that incorrect. Like that's totally acceptable. Conventionally, you want to write this as, you want to evaluate the 3s, you want to evaluate wherever you can. So if you have a coefficient to a power, actually do that. 3 squared is 9. I'm not going to hound you for that, but I guarantee you you're going to get hounded for it in subsequent years. So just so we understand that. Yes, Danny?
So when you distributed the 2, you put it on the, like, not, I would have, when I thought you said distribute the exponent, so you're distributing it onto the other exponents.
Yes.
On the 3.
Well, because that 3 does technically have an exponent.
Right.
The unwritten exponent is
Is 1.
a 1.
Okay. So you're really distributing it to the 1.
Yeah.
Okay.
So then the 1 times 2 is 2. Yeah.
Right, okay.
Okay, so that is law 3 and law 4 combined. Let's do one more law. I think there's only one more law today. Yeah, it's only one more law today. This is law 5. And this is fractions raised to a power. So we have a name for this as well. This is the power, you betcha, of a quotient. You will likely never actually use this language. You'll never say, oh, this is the power of a quotient. But the reason I'm calling it what I'm calling it is because the questions that I give you, they may say, simplify the power of a quotient. And you're like, what is this power of a quotient business? So that's why I'm introducing the language to you here. When you're actually given questions, because the last section we're going to do in the chapter is we're going to take all the laws together, and I'm just going to give you a single question. I'm going to be like, simplify. And you have to apply the correct ones without me telling you which ones to apply in whatever order you want, assuming you apply them correctly, to just simplify the question. And so I'm going to stop saying things like, well, give me the power of a quotient. I'm just going to say simplify, and then you do what you got to do. I'll give you an example of that today, right here at the bottom. So the last one we're going to do is the fractions raised to a power. So again, we're going to look at this one to give us what happens when I've got in the general expression. So here I've got 2 over 3 in brackets cubed. What does it mean to cube something? Times it by itself that many times, 3 times. So this is going to be 2 over 3 times 2 over 3 times 2 over 3. How do I multiply fractions together? Yeah, I multiply the tops together, and then I multiply the bottoms together. As I'm marking your tests, I understand it's important to review this. So what is 2 times 2 times 2? Don't say 8. 2 times 2 times 2, I could write as 2 cubed. You betcha. And then 3 times 3 times 3, I could write as, don't say 27, 3 cubed. So what's actually happening here? It's getting distributed. How, Kayla? Kyla? Ugh, sorry. I apologize in advance. I'm sorry. You're rattled now. I'm rattled now. I threw off the whole front corner. Kyla. So I'm distributing it onto the numerator and to the denominator. That's supposed to be an arrow. That doesn't look like an arrow. It looks gross. So in general, how would I write something like this? I've got x over y to the n. How would I write that? X to the power of n over 10 meet. Was that you? Awesome. Thank you. It's going to be x to the n over y to the n. Nice and easy, yeah? So we're going to get rid of this or business here because it's the same question. It's gone. And let's do these bottom 3. If I have 3 over 2 all to the 4, how can I write that? Yeah, this is going to be 3 to the 4 over 2 to the 4. And then if I wanted to evaluate that, I could, but I don't have to. Let's get, a little more interesting here. We're going to combine some stuff together. What do I do with this next one?
X squared.
That's a z.
Z. Why did I read X.
Because it's kind of cursive and hard to see. It's totally understandable. So you said, so the bottom's going to be z squared. Yeah, you're absolutely right. This 2 is going to get applied to the denominator. You betcha. What's going to happen in my numerator? Amina.
The 2 will be distributed to the power of
Keep going.
2,
Yeah.
and y to the power of 2.
Okay, so we're using law 5 to apply it to the numerator, but the numerator's got a bunch of things multiplied together. So it's going to get applied to the x squared, and it's going to get applied to the y squared. I'm going to finish it off. What am I going to get?
X to the power of 4 times y to the power of 2. I mean 4.
There you go.
Yeah, okay.
Questions about what she did? Danny.
So if we wrote that longhand, it would be x to the power of 2 times 2 times y to the power of 2 times 2?
Yes.
Okay.
And the last one, this is not the last one. I'm going to give you one more after this. Second last one. What's going on here? Careful. Look how it's written. Presley.
Since there aren't brackets around the whole fraction,
There's no brackets around the whole fraction.
the square only applies to the numerator.
Correct.
3 squared times x squared over 4.
3 squared times x squared over 4. You betcha. Which if I wanted to, I could write as 9x squared over 4. Cool. Got to be careful. You got to look closely at how things are actually laid out. Because the brackets aren't around the entire fraction, that exponent does not get applied to the entire fraction. Let's do one more really cool one. By really cool, I mean big and ugly. And it's actually not going to be as big and ugly as I say, but it's going to get more big and ugly. So here we go. I've got 3x cubed y squared over 4z squared. Do I want to give you more than that? Do I want to make it more interesting? What's coming up? Oh yeah, no, we'll save that. Okay, so then I've got this, and I'm going to take this thing, put the whole thing in brackets. I want to put that thing to the power of 4. So it looks it's more involved, like there's more stuff there, but it looks an awful lot like this question right here. So the procedure is going to be exactly the same, even though there's more present. Who wants to tell me what it is? Carolyn. So I'm going to take my, 3 to the power of 4. Which is? Yeah. Yeah, the 2 times 4 is the 8. Yeah. Cool. So to take this a little bit further, we could evaluate it, but that was not the path I was going to take here. Just to show you exactly what she did, and maybe this helps you, because when the questions get bigger, there's no, don't feel shame in not being able to carry the whole thing around in your head. To make sure that every piece gets dealt with, draw the arrows in. You're like, okay, well, I'm going to apply it to the numerator, and I'm going to apply it to the denominator, but I need to apply it to everything in the numerator, so it's going to go there and there and there. And in the denominator, it's going to go there and there. Actually draw it all out, and then do each piece. 3 to the 4, x to the 3 times 4 is going to give me the 12, y to the 2 times 4 is 8, and then here I'm going to have the 4 to the 4, and the z squared to the 4, 2 to the 4 multiplied together is going to be the 8. Do draw those arrows to make sure you get every piece, because the questions are only going to get bigger and more awesome. Look at this. This is what's coming. But the rules, again, this is just an application of the rules that we've seen, right? Actually, I lied. Let's look at this one instead. It's not bad, right? This is exactly what we did. This -3 is just going to get distributed into the numerator, and it's going to get distributed into the denominator. Well, it's going to go onto the 2 and the there. And then this guy's going to go there and there. But then that's just going to go in there and in there. I know you're desperately trying to flip to it, and I'm not going to finish it. That's as far as I'm just going to show you a little bit. Don't worry about it. We'll get there. Don't worry about it. We'll get there. Probably tomorrow. Maybe Friday. Okay? Are we cool with this? Ish? Like what you got it, just whatever happens, what you got it, and as the questions get larger and larger and larger, you just got to keep reminding yourself. It looks complicated, but these are just applications. It's just multiple applications of relatively simple rules that you've already seen. Danny.
So, is there a certain way you should, like, because there's, what, five laws? What were the other two?
There are more than 5. There will be more than 5.
5 so far.
There will be a total of 7.
Oh, okay. So are we supposed to apply them in order, or just apply them how we think they should?
Apply them as the winds of math blow you around, like leaves through
But it's not like
mathematical world.
that math thing where you have to.
No, they can be. You can apply them in any order.
Okay.
As long as you apply them correctly, you can apply them in any order. Yeah. That's coming. That's yes. Okay, so I want everyone to flip the page because Angel's taking us to where I was going to go next anyway. Okay, so let's talk these through. I want y'all to try question number 1. Just one, real quick. Give you 10 seconds. Yeah, give you 10 seconds. Do your best with it. 2, 3, 4, 5. Oh, I'll give you mine on my phone call. Guten Tag. You betcha. I just haven't had a chance to bring them up yet. Do you want the whole cart? Yeah, man. Come. You betcha. Back. And who's done? Okay, wait, no, we just did it. Okay. 5, 4, 3, 2, 1. Okay, cool. Someone who's got it, tell me what you did. Rebecca. Distribute it and put it to everything inside. Okay, so it's going to go there, it's going to go there, it's going to go there, and it's going to go there. So, distributing that thing in is going to give me what? Okay, and you want to be careful with the negative. You want to put the -5 in brackets because that squared is that it's on the whole thing. So it's going to be -5 squared, x squared, y squared, z squared. And then my last step is to do what? Yeah, Rebecca, I want to evaluate where I can. So what can I evaluate? My final answer is going to be? Careful. -5 times -5 is going to be? Positive 25. X squared, y squared, z squared, and we're done. Okay, 10 seconds to question 2. Go. 10, 9, 8. I'll count in my head. Hey, is that Hatisha in the hallway? You guys keep going. Hatisha. Hatisha. What? It's not Hatisha? You sure? Who is it? Oh, that's Mantoj. All I saw was your shoulder. Because Hatisha skipped my class this morning. And so if she was here for period 2, we were going to have a conversation about that. Okay, time's up. Number 2. What'd you get? Final answer, Nika.
I'm just going to take a guess. I'm just going to say anything.
You know what? I love it. Guesses are great.
Okay, would it be, it would start with -3 bracket. Wait, do you want the evaluated answer? Or just
Do you have an evaluated answer? Okay, what is it? Final answer.
-81 in brackets, and this
are like so close. The only snag is that -3 to the 4. -3 to the 4 is an even exponent. It's going to be positive 81. Good, love it. You fixed it. That's what you're looking for. Thank you, Nika. Oh, I know, and I was counting down, I was putting pressure on you guys. You guys drop negatives. It happens. Don't worry about it. I mean, I'm going to take a half mark off every time it happens, but, you know, in general, don't worry about it. You'll fix it. Okay, number 3. 7 seconds. Because it's easier. Carmen, what'd you get? You slam your pen down. Kyla. 16 next to the 10. Love it. Hands up if you have questions about what you... If we're going, you're like, I didn't get that. Oh, it's too much pressure. If you have questions, ask. Okay. So, I am going to leave... Oh, Danny. Oh, hold on. I'm going to leave 4 and 5 for you guys to do on your own, and we're going to jump down to 6. Let's talk about 6. Okay, if this was the question, it's just like what we did, right? If this was the question, it's just like what we did, right? Well, how do I multiply them together? Okay, so someone rattle off the left bracket for me. What is this going to be? Someone can do it fast. I want it to be someone who's hasn't given me something yet. We're starting to rely on the same set of people. You're part of that set of people. I hear nothing from this back corner on my side of the class. Like, nothing. Like, they're all so quiet. Just give me the left bracket, someone. Fine, I'll take it from you. 6 to the power of 2. And if you want, you can take it straight to the evaluated. Is going to be? Will be 36, yeah. X to the 2. Y to the 6. Cool. Who's got the right-hand bracket? And then this is times. The right-hand bracket is what? X to the 15. Y to the 10 meet. Was that you? It was Angel. Y to the? And Z to the 10. Okay, cool. So I've used my most recent set of laws. Now let's go back and take a look at the old laws. The old law said when I multiply, I add exponents. So do I have anything to multiply the 36 with? No, so it's just going to be 36. Do I have a same base to multiply the x with? Yeah, I got another x. So what am I going to do with these two exponents? So it's going to give me x to the? It's going to give me x to the 17. So it's going to give me y to the? Kyla, you just said it? Y to the 26. And z to the 18. See? Nice and easy. It's easy. I used to have a teacher who she had a little bit of an accent. It's easy. She was Eastern European. It was great. Number 7. We cool 7? Okay, so the double brackets are what's throwing you off because you asked about 8. So let's talk about the double brackets now. If I had this, what would I do? I distribute the 3 in and to the 2 and the 3 into the x. So we can do that. Let's distribute that 3 in. So it's going to give me 2 cubed x to the 3. And now I've got that whole thing squared. It doesn't matter. Might make your life easier or harder, one way or the other. Carolyn? So Carolyn's evaluating it. So that's going to 2 cubed is 8, and she's going to square that. Keep going. X to the power of 6. So then 8 squared is 64, and I'm done. So you don't have to do it all in one shot. You can show your work each step of the way. So we applied the inner bracket first, and then we applied the outer bracket. But that's not the only way we could do this question. We could do it a different way. Let's do it this way over here. What if this was just x cubed to the power of 2? What would I do first? If it was just, if the 2 wasn't there, if just this is just x cubed squared, what would I do? So I'm multiplying the exponents together, right? So if I want, that could be my first step. I say, okay, well, I've got a power to a power, so I'm going to multiply those exponents together. So I'm going to get 2x to the 3 times 2, which is going to give me 2x in brackets to the 6. And now I would do what? I would just distribute it. So this is going to give me 2 to the 6, x to the 6. And we could do 2 times 2, which is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. And we're done. So like I said before, it doesn't matter what order you apply the laws. What matters is that you apply them correctly. Questions about anything?
Can we do number 12 today?
No. Because 12 is just a combination of all the ones we've done before. So here's what I'm going to do. I'm going to give you a chunk of homework, including 8 through 13. I will give you the answers to those before you leave. So 8 to 13 is homework. Oh, and 4 and 5. Yeah, 4 and 5. Couldn't forget about those. Thank you for those of you who reminded. What about 4 and 5? Yes, that. And then, oh boy, I want you to do, should I make a smaller? Because 4 and 5, 6, they're all, and 7, they're all super easy. 8, oh yeah, like they actually should be. 14. Okay, so here I'm going to change this a little bit. Here, okay, here, take a look. We're going to change the questions a little bit. Because they're nice and easy, I'm going to shrink this down for you a little bit here. I want you to do where it says 4 to 11. I want you to do, lots of these have like A, B, C, D, E, F, G or whatever. I want you to do 4 to 11. Wherever there is multiple letters, do A, C, and E. So 4, ACE, 5, ACE, 6, ACE. 7 is only one question. 8, you'll do ACE. 9 is only one question. 10, you'll do ACE. 11 is only one question. 14, I want you to do ACEG. 16, I already shrank for you. Oh, no, can't forget this one. I'm going to add a question. I want 15, A, C, and E. 16's already ACE. 17's already ACE. 19's already ACE. And I want you to do question. Oh, yeah. These two as well. Where it says too easy, keep going. You're pre-diploma. You're just going to keep going. It looks like there's a lot, but a whole bunch of those are super simple. If you can do these ones, then 4 to 11 is going to be a cakewalk. Here's what I want you to do. Any market say giver. That's your homework. Go. Okay. Okay, I'm putting it in the video, so if you are cool to wait for the video, you can take a look there. But if you don't want to wait for the video, take a picture of the screen. These are the answers to that first chunk. 4, 5, 8, 9, 10, 11, 12, and 13. The answers to everything else is in the, what's it called? The textbook answer key that I've given to you. So there it is.